Dear students, welcome to our class on fluxes, momentum flux, heat flux and mass flux. So what is momentum flux? Momentum flux follows the Newton's law of viscosity. What Newton's law of viscosity states? Shear stress in a flowing fluid is directly proportional to the velocity gradient. Once again I will read. Shear stress in a flowing fluid is directly proportional to the velocity gradient. If you take a fluid and the shear stress is directly proportional to the velocity gradient. Now, momentum flux is the transport of momentum that acts in a direction perpendicular to the direction of the fluid flow. It is considered as the rate of change of horizontal momentum, which is moving across a unit area equal to the force per unit area. Momentum flux can also be generated by gravitational waves. There is a small difference between momentum flux and pressure. Momentum flux is generated by thermal properties. Pressure, as you know, is an additive factor to the momentum flux. What is additive factor? In other words, pressure is associated with the momentum flux. So this is what I would like to say. What the Newton's law of viscosity says that shear stress. Say for example, this is a plates. These are the plates. If we apply the strain, this is the area. This is the force. Okay, force by area sharing stress F by A. What is the shear rate? This is the the relation between shear stress and the shear rate is Newton's law of viscosity. That's why F by A. Here E by T. What is E? Strain, displacement by thickness. Okay, this is the thickness of the fluid. Displacement is from here to here, S H. Okay, S by H. This is the S displacement. This is the thickness. Okay, so shear rate is E by T. That's what we get it. So this is what we call it as the momentum flux. And the next one is the heat flux. Temperature is defined as measure of speed per molecule of all the molecules of the body, whereas the heat is the energy. That's why heat is the energy arising from random motion of all the molecules of the body. That's why heat flux or energy flux, we say the same. Okay. Now, so what is the heat flux? Not usually, in all the likelihood, heat flux follows Fourier's law of thermal conductivity. Fourier's law of thermal conductivity is the basis for the heat flow or energy flow. Now, see the thermal conduction. For example, take this small, just a small basic class only. This is a plane, this is a plane, this is a T2, this is a T1. T2 is hot, T1 is cold. Now this is a conducting solid. Hot environment, cold environment. What is the heat flow? That is the thermal. What is heat flow? X is equal to 0, X is equal to L length. Now heat flows from T2 to T1. Hot to cold. Heat conducting solid, heat flow. Heat flow is Q. Now the heat flux follows the Fourier's law of the heat conduction or Fourier's law of thermal conduction. Now thermal conduction is the transfer of thermal conduction, conducting solid. Thermal conduction is the transfer of internal energy. There is an internal energy. Okay, conducting solid. This is the solid internal energy by microscopic collisions of particles and movement of electrons within a body. Within a body, movement of the electronic particles movement. It is also the colliding particles include molecules, atoms, and electrons transfer disorganized microscopic kinetic and potential energy. Disorganized, there are two energies, kinetic and potential energy. Together we call it as the internal energy. This follows the Fourier's law of thermal conductivity. Okay, simple equation is delta Q by delta TA is equal to minus K. thermal conductivity into dt by dx. Heat flux is also known as thermal flux, heat flux density, heat flow density, heat flow rate, intensity. What exactly is it? Once again I would like to tell you, a flow of energy per unit of area per unit of time. This is what we call it as. This is the heat flux. Earlier we tried to understand the momentum flux. Now this is the heat flux. So what is the third one? The third one is the mass flux. Mass flux. What mass flux follows the Fick's law. F-I-C-K-S. Fick's law. What is Fick's law? Fick's law says very interesting. The rate of mass flow is mass flux. The common symbols are small j, capital J, small q, big Q, all these things are there. Okay, now see, Fick's law of diffusion says the molar flux, high, low, high concentration, low concentration, the molar flux, okay, due to diffusion is proportional to the concentration gradient. Molar flux is proportional to the concentration gradient. This is what. So movement of the particles high to low concentration, random. This is a passive process. Okay. It states that the rate of diffusion is proportional to both surface area and concentration difference and is inversely proportional to the thickness of the molecules, thickness of the membrane. What? Okay, so this is what I would like to say. Now here all these things in a simplified way I have given. What is it? Conduction, okay, of momentum, energy, that is heat and mass. So momentum flux, okay, shearing stress, mu du by dz, Newton's law. Energy flux, F H, okay, minus k dt by dz, Fourier's law of conduction. Mass flux, Fm, okay, Fick's law. Okay, this is what. This is dynamic viscosity here. D. What is the D here? Diffusion coefficient. What is K here? K is heat conductivity. Of course, dynamic viscosity is related to kinematic viscosity. V as mu is equal to rho V. So, of course, this is a simplified version. As a chronometrologist, we also should know very interesting things. Slightly advanced one. The momentum flux tau minus Km rho du by dz. So tau is the surface shear stress. This equation we should know. Second thing is, as far as heat flux is concerned, okay, rate of heat flow, capital H is equal to minus Kh rho Cp dt by dz. Kh is the thermal conductivity, T is the temperature. As far as mass flux is concerned, flux of water vapor is E, what we call the flux of water vapor, capital E, minus Kw rho Cp by psychrometric constant dE by dz, where E is the molecular weight of water vapor and dry air. So these are the things. Finally, carbon dioxide flux, F. E is equal to mass flux. F is the carbon dioxide flux. F is equal to carbon dioxide flux minus Ks ds by dz. S is the flux of gas. This is what I would like to tell. All these things I covered. Basics. This is the fluxes basis class. What we try to understand are momentum flux, heat or energy flux, mass flux. In the mass flux, two are there: water vapor and carbon dioxide. Simply Newton's law of viscosity as far as momentum. Fick's law, okay, as far as mass. In between, Fourier's law for heat flux or thermal flux. Thanking you very much for your patience here.